Welcome to aminacademy.com. In chemistry, let us discuss about changes in enthalpy during chemical reactions. The enthalpy change of a reaction is roughly equivalent to the amount of energy lost or gained during the reaction. The reaction is favored if the enthalpy of the system decreases over the reaction. Changes in enthalpy accompanying the reactions. Changes in enthalpy occurring during reactions. A change in enthalpy during a reaction depends on many variables, but temperature is one of the most important variables. To standardize the enthalpies of reactions, data are often presented for reaction in which both reactant and products have the standard thermodynamic temperatures, nearly about 25 degrees Celsius or 298.15 degree Kelvin. Next, in chemistry, the thermodynamics calorimetry, that is apparatus, is very useful. This is the science, the chemistry in thermodynamics. Calorimetry is the science or act of measuring change in state variables. If a body of the purpose of deriving the heat transfer associated with changes of its state due, for example, the chemical reactions, physical changes or phase transitions under specified constraints. Calorimetry is performed with a calorimeter. Scottish physician and scientist Joseph Black, who was the first to recognize the distinction between heat and temperature, is said to be the founder of the science of calorimetry. Chemical calorimetry we will discuss further. For H2, for example, for H2 and Br2 reactions in which delta H is negative, the total energy of the reaction decreases. Energy cannot disappear, so what happens to that energy? The energy is released as heat by the system. If the reaction was endothermic, energy in the form of heat would be absorbed by the system and the enthalpy would increase. The experimental measurement of an enthalpy change for a reaction is called calorimetry. Combustion reactions such as the reaction of combustion are always exothermic. That means it releases heat. The enthalpy changes of combustion reactions are determined by using bomb calorimeter, such as one is given in the figure. This instrument is sturdy steel vessel in which the sample is ignited electrically in the presence of high pressure oxygen. The energy from the combustion is absorbed by surroundings, water, bath, and by other parts of the calorimetry. The water and the other parts of the calorimetry have non-specific heats. So a measured temperature increases can be used to calculate the energy released in the combustion reaction and its enthalpy changes. This is a really bomb calorimeter. Bomb calorimeter measurements an apparatus that can measure heats of combustion used in various applications such as calculating the calorific value of food and fuels. In that we are using bomb calorimeter. In principle of an adiabatic calorimeter, is one in which heat is confined to the calorimeter, usually by surroundings it with a adiabatic shield maintained at the temperature of the calorimetry. In practice, temperature gradient in the calorimeter and shield cause net heat exchange during the experiment. This is an adiabatic calorimeter. We will discuss further about this one. Instead of using water bath on to absorb the energy generated by a chemical reaction, adiabatic calorimetry uses an insulating vessel. The word adiabatic means not allowing energy to pass through. So no energy can enter or escape this type of vessels. As a result, the reaction mixture increases in temperature if the reaction is exothermic, or decreases in temperature if the reaction is endothermic. If the system specific heat is known, the reaction enthalpy can be calculated. Adiabatic calorimetry is used for reactions that are not ignited, such as for reaction in aqueous solution. Now we'll discuss Hess law. Hess's law of constant heat summation, also known simply Hess law, is a relationship in physical chemistry named after Germain Hess, a Swiss-born Russian chemist and physician who published in 1840. The law states that the total enthalpy change during the complete course of a chemical reaction is independent of the sequence of steps taken. That means the chemical reaction is independent of the sequence of steps taken. Here, look at here, the reactants become product when delta H is given. Here, this is the schematic explanation of the Hess law. Further, we will discuss about Hess law. Any two processes that both start with the same reactant in the same state and finish with the same products in the same state will have the same enthalpy changes. This statement is the basis of Hess law, which states that overall enthalpy change in a reaction is equal to the sum of the enthalpy change for the individual steps in the process. Using Hess law and algebra, chemical equations can be manipulated using rules of algebra to get a desired equation. When equations are added or subtracted, enthalpy changes must be added or subtracted. And when equations are multiplied by a constant, the enthalpy changes must also be multiplied by that constant. This is basics for algebra. It is useful in Hess law to find the equations. Next we will discuss about standard enthalpy of formation. The standard enthalpy of formation of a substance is the enthalpy changes that occurs when 1 mole of the substance is formed from its constituent element in their standard states. A pure element in its standard states has a standard enthalpy of formation of 0. The enthalpy change in forming 1 mole of a substance from the element in their standard states is called a standard enthalpy formation of the substance. We can write as this as delta H of 0. In fact, enthalpy change of any reaction can be determined in the same way. The reactant can be converted to their elements and the elements can be recombined into the products. Hess law states that the overall enthalpy change of reaction is the same whether the single step process or multiple steps process. If you apply this rule, the exothermic reaction that forms sulfur, for example, sulfur trioxide and nitrogen oxide has the enthalpy changes like in the equations. It will be given in the equations. Now, we have done. Please subscribe our YouTube channel.